Ever stop and wonder how your inbox just knows what's junk? Or how your bank can flag a weird charge on your card, like instantly? Well, behind a ton of these daily yes or no decisions is a powerful, yet surprisingly simple algorithm. So let's pull back the curtain and see how it all works. I mean, think about it for a second. Every single day, your email looks at a message and has to make a call. Is this important or is it spam? It's a binary choice, one or the other. How in the world does it actually decide? Or here's another one. You go to buy a coffee, you tap your card, and in a literal split second, your bank has to figure out, is this you or is this a fraudster? The stakes there are super high, and that decision has to be both lightning fast and dead on accurate. Well, the secret sauce behind all these predictions isn't really magic. It's an incredibly common tool from the world of machine learning, and it's called logistic regression. And today, we're going to break down exactly how it does what it does. All right, first things first, let's get a real handle on what this prediction machine is all about. So, here's the most important thing to get right away. Even though it has regression in its name, it's not for predicting a number, like the price of a house. Its whole job is classification. It looks at the data you feed it and spits out the probability, a number between 0 and 1, that something belongs in one of two buckets. And you can see just how much this thing gets around. I mean, is a customer going to leave? Does a patient scan show signs of a disease? Will a student pass? And of course, is this email spam? Anywhere you need a simple yes or no, logistic regression is pretty much the go-to starting point. Now, you might be thinking, okay, if we're predicting stuff, why not just use a tool that draws a straight line through the data? It seems obvious, right? Well, it turns out that creates a pretty big problem. I mean, linear regression is a thing, right? It's fantastic for predicting values that can go up and up. You give it data, it draws the best fitting straight line. But what happens when you try to force that straight line to answer our simple yes or no question? And here's the issue in a nutshell. A straight line just keeps on going forever in both directions. It could predict a value of 150 or maybe -2. But what does that even mean? How can you have a 150% chance of something happening? Or a negative chance? It just doesn't make any sense. We need our answer to be stuck between 0 and 1. So how do we fix this? How do we take the basic idea of a line but force its output to be a nice, sensible probability? Well, this is where the hero of our story makes its entrance, and it's a really elegant solution. What we need is basically a mathematical squisher, something that can take any number, no matter how huge or tiny, positive or negative, and just gently squeeze it into that perfect 0 to 1 range that we need for probabilities. And that squisher has a name. It's called the sigmoid function. You can really think of this as the heart and soul of logistic regression. It's the special gear in the machine that takes a raw number and turns it into a clean, easy-to-understand probability. And just look at how intuitive this S-curve is. If the model is really sure in a positive direction, the sigmoid pushes the result way up, close to 1. That's a definite yes. If it's really sure in the negative direction, it gets pushed down near 0, a clear no. And what happens if the model has no idea, if the input is 0? The curve goes right through 0.5, which is basically the machine shrugging and saying, 50-50, I've got no clue. Okay, so our model is now giving us a nice, neat probability. That's awesome. But we still need a final answer, right? A yes or a no. So how do we get from that probability to an actual final decision? Let's make this real. Imagine we built a model to predict if a student will pass an exam based on how many hours they studied. For one student, our model spits out this probability, 0.78. So, a 78% chance of passing. 78% sounds pretty good, doesn't it? But how does the machine actually make the call? It can't just feel that it's good. It needs a hard and fast rule. And that rule is called a decision boundary, or a threshold. The standard default setting for this is almost always 0.5. The logic is as simple as it sounds. If the probability is more than 50%, we'll call it a yes. If it's less, we'll call it a no. So for our student, since 0.78 is obviously way bigger than our 0.5 cutoff, the model confidently predicts pass. And just like that, we've gone all the way from raw data to a clear, actionable prediction. Pretty cool, right? All right, now that we've got the mechanics down, let's zoom out and just appreciate where the simple but incredibly powerful algorithm is quietly shaping the world all around us. Seriously, the applications are just about everywhere. In healthcare, it can help flag the likelihood of a disease based on a patient's chart. In finance, it's the first line of defense against credit card fraud. Marketers use it to figure out which customers are about to walk away. It is a true workhorse algorithm across countless industries. So let's wrap this up by taking a final look at the big picture. What makes this algorithm so special? And just as important, what are its limits? Its biggest selling points are its simplicity and its speed. It's not a heavy lift for a computer to run, and the results are super easy for us humans to understand. That probability it gives you isn't some black box mystery. It's a clear measure of confidence. That's why it's the perfect starting point, the baseline, for almost any classification problem you can think of. But, of course, it's not a silver bullet. Because it's fundamentally based on a line, it really struggles when the patterns in the data are all curvy and complex. It can get thrown off by really weird extreme outliers, and for super complicated problems, more advanced models like neural networks are definitely going to do a better job. So there you have it, the secret engine chugging away behind so many of the yes or no decisions that shape our digital lives. It's really just a simple, elegant combo of a line and a curve that brings order to all sorts of messy data. Which kind of leaves us with one last thought. Now that you know how it works, what's a simple yes or no question about the world that you'd want to predict?